Okay, so now we're going to take a look at how to set up triple integrals for more general solid regions where the solid region Q can be bounded by curved surfaces described by functions of two variables. So the solid region Q can sort of be oriented in different directions, but we're only going to look at the specific case where the top and bottom boundary for Q is described by functions of x and y. Right, so here the top boundary for Q is described by a function g2 that depends on x and y. The bottom boundary is described by the function g1, again, that depends on x and y. Okay, so that's how we're going to set up the solid region Q. And then to also finish up describing the triple integral, we'll also need to look at the two-dimensional region in the xy plane that you obtain by projecting the solid region down into the xy plane. So again, because now the region Q is curved, the downward projection can also be a curved region, and this region R can be either a type 1 or a type 2 region. Okay, so this is the basic setup, and so that's described here, right? So we're looking at a solid region where the x and y is within the region Q. That could be a type 1 or a type 2 region, and then z is bounded above and below by g2 and g1. Okay, so the way we set up the triple integral, so because the top and bottom boundaries are exactly like this, for this triple integral, the variable z has to be the innermost integral, right? Because z depends on both x and y. And just like for double integrals, if your upper and lower limit depends on certain variables, then in the integral, those variables have to be integrated later, right? So here this depends on x and y, so the innermost integral has to be with respect to z. Okay, so that's the innermost integral, and then once you complete the inner integral, you're left with a double integral, and it's just described like this over the region R, because the region R could be a type 1 or a type 2 region. And so after integrating with respect to z, it could be either dy dx or dx dy, again, depending on whether R is a type 1 or a type 2 region. Okay, so that's the basic setup. So again, as I said, the innermost, for this setup here, the innermost integral has to be with respect to z. And I mean, you can have different orders of integration if the solid region Q is set up differently, right? So it could be bounded front and back, or it could be bounded left and right. And then so the ordering of the integration would be different, but to keep things short, we only describe top and bottom surfaces, right? So you can imagine it should be bounded front and back if you want the dx to be first, and it should be bounded left and right if you want dy to be first. And you can imagine how the integral should be set up in those cases. Okay, so that's the basic idea. So next we're going to take a look at an example where we calculate an integral like this.